Excellent.
There's
So,
the slides. Good.
all right. So this is an update specifically on the occultation program with the Unistellar network. So I'm gonna maybe repeat to people what is the Unistellar network and what we do. So Unistellar is a private company. We develop digital
Frank,
telescopes. Yes.
excuse me, your screen is very, very small.
Ah, the beauty of Zoom. Let me just try something else. That. Just stop sharing this and share again, but maybe just sharing my IOTA, my presentation here. Is that better? Is it better or no?
Yes,
Yes.
better, but
Uh,
you have to go to slideshow
I think
mode.
it's a different slideshow, different
uh,
presentation.
Yeah. We still see your slide, small slides on the side and your menu bar at the top,
I show meeting.
but it's
What?
bigger.
So
Yeah.
you don't see my presentation in presentation mode?
Try starting the slideshow again for this one.
Okay. All right, let me just do that again.
Let's see if that's any bigger.
Better?
Uh,
No?
No change.
No change?
we're not seeing the. You're still sharing the PowerPoint window instead of sharing the PowerPoint
Okay,
presentation
okay.
window,
Okay, sorry.
which is somewhere else on your computer,
Yes,
probably.
probably because I have multiple presentation open and I probably share the wrong one.
Yeah, I understand.
Is that better? Now
Okay,
you should see the title, right?
we
Yeah.
do
Here should be in
see
full screen.
we see the right presentation, and again, for some reason, the presentation is small on the screen compared to the other
It's about one third of the total size.
Oh my
screens.
God.
Yeah, that's
Frank, it's because you're in presenter mode. If you can get rid of the presenter mode where you don't have, the next slide small on the side,
Yeah,
that should get rid of this problem.
I am not here on presenter mode. That's a problem. I'm on my, let me just, I need to switch screen maybe. I don't know. Is that better now? No? I
no,
do that every day, so I'm surprised that I can't
Uh,
get this working
I
today.
know. Well,
now we have two screens.
Oh,
right.
goodness.
I,
Okay.
right.
Look, what we're gonna do, spending a lot of time on that. Oh my God. Yeah, now I see everything in multiple version. Okay. I'm gonna grab my screen, make it big, and present it directly on my screen. Maybe
Oh,
that's gonna be the better way. Still not, huh? What do you see? My entire screen now?
Yes.
Okay.
About two steps back, you had one that was mostly your presentation with small thumbnails on the right, on the left-hand side. You could go back to that. That might be best.
Okay. Uh, I love the new still in presenter mode.
We don't
that
know
that
yet
looks
until you go
pretty
to full
good.
screen.
Oh, that's a little better. I think we can go with that.
Can we go with that? I don't know what you see, so I'm sorry.
Yeah, we can
Okay.
read it.
Okay, so Unistellar, we started in 2017 with a Kickstarter. Now we have 4 different type of telescopes. This is the Equinox to give you an idea of the size. 10 kilogram. You can carry it in a backpack. And this is the new model that we released last in January, is the Odyssey. Super small, easy to carry around, tiny backpack you can carry in a plane. So we're really trying to make it even more compact and easier to use. Detector we use is the CMOS detector, as everybody else. The goal is to make a telescope which is easy to use for everybody. People control it with an app. Is powerful enough on board that it can point by itself, find the targets. He has this kind of astrophotography live that we call enhanced vision. He has a time accuracy coming from the phone, which is typically 70 milliseconds or less on an Apple iPhone with 4G connection. And we have sold more than 15,000 of them. So it's a success in terms of becoming the largest network of telescopes in the world. The price changed significantly over time. We have now a $2,000 model, the Equinox 2, and the high-end one, which is TV Scope 2, 4,500. So people come for the pretty picture, definitely. This is what they've seen our advertisement, and that's the reality. If you have not seen one in action, I recommend you try. We do stacking astrophotography live, so in a few minutes, even in cities, we have an algorithm specifically for that. We can get rid of the pollution, so people can see galaxy, nebulae in color and comets. We're gonna announce. We already announced the new software. So the software on board the telescope evolves over time. Every 3 months, we basically release a new version. So sometimes there is a change which is related to the image quality. So that's going to be the case in October. We're going to have this new image processing algorithm called the Vivid Vision, which allows to see better in color. So I can look at the image on the right. It's before and after the Vivid Vision. You can see an improvement significantly. And we also improve the science on board the telescope by adding new features, new science mode, etc. I want to say that we have a program with the Moore Foundation. So we have those telescopes distributed in community colleges, high schools around the country in the US. We have more than 50 of them, which has been donated to community colleges. And they use them for the astronomy program with the instructors, but they also use them to do citizen science. So that's truly a way to attract young people to the field of astronomy. We have some successful stories like the Galaxy Explorer program at the Chabot Space Center here in Oakland. Bought several of our telescopes. The students use it. They're part of the Star Party program of the place, but they also do scientific investigations. So they publish, for instance, a paper on the detection of exoplanets this year with my graduate student Daniel. So we also do outreach with this project. We go around the countries. We have done one, for instance, in this case for the eclipse in April. We have multiple stations. We show live the eclipse. We have more than 10,000 people watching us on our YouTube, Twitter, etc. page. So again, very young audience, very diverse, representing the diversity of this country that we love, and also bringing young people to the field of astronomy. We're also growing the network, so we have more people outside the US to get access to it. We donate telescopes in astronomy clubs around the world. If you know some and you think they could be interesting, let us know. We have a program for that. We work with the Astronomer Without Border and Astro Sandbox to bring telescopes in Ukraine, in Kosovo, in Brazil, in Armenia, etc., etc. So this is really the idea of having more people using our telescopes and also more people doing scientific investigation. So currently the network has more than 15,000 telescopes, as I mentioned. This tiny dot here shows the evolution of the number of telescopes over time from 2019 to 2023, and you can see the increase. We have a majority of our users located in the US, Europe, Japan. We're growing now in the Southern Hemisphere, especially in Australia and New Zealand, and in Chile and Argentina. We are now also having distributors in India, Arabic Peninsula, and in some countries in Africa. So among these 15,000 people who have telescopes, 2,300 of them register to our Slack to become citizen scientists. So we have developed citizen science programs specifically for this telescope. And today I'm going to talk about the occultation program that we have now put in place with Charles University. Charles University joined us as a partner officially in June of this year. And that's allowed us to get more manpower working on the occultation program. So this is the way it works. So Unistellar is a private company. I'm a co-founder of the company, but and director, chief scientific officer. But I also work at the SETI Institute as an astronomer. And the SETI Institute signed an MOU with Unistellar. So we develop the citizen science, the outreach, and the education of Unistellar. So when you hear me talking about science, I'm talking on the name of the SETI Institute, basically. That's not about for Unistellar. And these are the partners that we have for our citizen science program. You recognize IOTA. We've been working with IOTA for years, since the beginning, in fact, of the project. And I appreciate the help of some of you who guide us in finding the right science and the right way to do this science. And I appreciate as well the inputs that you provided over the years, even the negative one. He helped a lot to make this project a reality, and I think improving it over years. These are the people. So those are, each of us lead different citizen science programs. If you work with us, you basically probably heard by myself, but also Lauren is our kind of connection with the world, the outreach, with Ian, does education. But the most important for you is the fact that Joseph Anush from Charles University joined us recently and become our lead for occultation. And this is not funded by Unistellar. This is funded by the Gordon and Betty Moore Foundation that provided a grant for this program, which is going to last for 2 years. After that, we need to discuss about what we're going to do. So a citizen science pipeline works quite simple, very simple. You observe, you upload the data, we do the analysis, we send basically the procedure of observations. When the data being received by our cloud server, which is on Google, we do photometric and photometric analysis. We have some AI algorithm that detect automatically what the data are, if there was an occultation, and so on. We're really trying to minimize the amount of human being involved in this. So at the end, you get a report that will be posted on Slack. And this is going to change over time, since we are opening now some kind of user account. So if you go to our website at science.unistellar.com, you can see our science live. So for instance, you can see a diagram like this that show you who has been taking data and send us data over the past 24 hours. So you can see different categories of observation and science. So you can see occultation is this orange label. So we see those data coming. And if you go to our other page, you can see the processing of the observations being done by our pipeline. So this way you can detect, if you send us data, you can detect automatically where the data, if they have been taken, received, and if they have been processed. And that's, again, on our website, we also have predictions and so on. And this is not only for Unistellar users, it's for everybody. Everybody has access to our citizen science campaign. We do not process data coming from other telescopes, however. So I'm not going to talk about all the science you have done over the years. I'm going to focus only on the occultation events. But we do planetary defense, exoplanet, cometary activity. We opened recently cosmic cataclysms, which is basically nova, supernova. And in a month, we are going to have a new one, which is the study of artificial satellites. So this is what it looks like when you do an observation. So this is the field of view of our telescope, typically the size of the moon or the sun. The star is being labeled here, that's the star that's going to be occulted. And you will see the star disappearing, this one, in a few seconds. And this is the light curve. Okay, this is generated automatically once again by our pipeline. When this is done, the pipeline also generates a report that is sent to the user. So here's positive detections, some basic information, the observer, the location of the observer, and so on, the light curve, etc. So this is a way for the users to kind of know what happened to his data, and also to have some physical, not a physical, but some kind of report that they can use, post, and some of them frame them in and put them in the office. So the prediction are calculated once a month. Typically the 15th of August for the month of September, we post the occultation. We curate them, so we do occultation that are observable, knowing our telescope and its capabilities. So magnitude less than 11.6 at the moment, duration greater than 0.5 seconds, brightness drop upon 9 magnitude, and the size of the asteroids bigger than 5 kilometers. That's 9,000 occultation each month. This is done using the Occult software, by the way. And then we post them on our website. We prepare the observation, the observing sequences, and so on. That's a deep link. People press the deep link, and that's open the app, and they observe. It's very an attempt to simplify the way you can do occultation observations. There is still some tweak we can improve, but we are getting a lot of observation because of the simplicity of the process. Something I want to mention, I'm going to say it multiple times, is that if you have an occultation that you want us to include in our phone network, we can do it. I mean, we have observed occultation involving star magnitude 13, 14, and duration of 30 seconds. We have done that in the past. So if you have something and you really would like the Unistellar network to know about it or to attempt to observe it, we can do that as well. Those are some results. You may have seen those already. Those were Varsavia, there's a grazing occultation, the Cichaldea, and Otilia that was observed in 2020 and 2021. We focus essentially now on promoting occultation for which we have an interest for the asteroid, which is because there's a space mission dedicated to it, or is because it's a near-Earth asteroid. That's the decision that was taken by Joseph and myself. So we kind of prioritize the science output for the year 2024. We have done some attempts of dimorphos occultation. We went all the way to Oman to do that before the position of the asteroid and its satellite was well known. So we have zero detection. It cost a fortune. A lot of people went there for us, but it was a fun project because it allowed us to connect with the people in Oman, and they now basically bought more than 10 telescopes, and they're using them regularly to do occultation. So even if an occultation is negative, the fact we go there, we connect with people over there locally is very useful. After the orbit has been reassessed and so on, we did another attempt, and this is a positive occultation taken with a telescope of Didymos and Dimorphos. So you can see the occultation of the primary and the secondary. This is still not published. We sent this data to the team in Nice quite a while ago, and to my knowledge, they not have published that yet. But that's the first detection of a moon, the Dimorphos, the moon of Didymos, using our telescope. We have done some more recent observation of smaller asteroid to learn as well how our telescope behave for occultation, which lasts on less than 3 frames. So this is one by for the asteroid Oerst, and one of them here is our core. I forgot which one, but you can see that we have a good shape model for this occultation that was visible in Czechia. We motivated our network, so we have 2 calls or 3 calls coming from our network, but also we use the network, the SOTIS IOTA network, to motivate other observers. So that's why we have more occultation calls, positive occultation call for this object. And this is going to be published by Joseph in the near future. If you want to see how it works, let me just give you a very concrete example here. So you have an app. So that's the app, that's the screen of the app. You join the citizen science program. When you have joined the citizen science program, you can choose different type of programs. So let's say you're interested in predictions, in occultations. So the first thing you do is you go to our prediction page, you enter your location, you choose the program you want, and it will generate automatically all the occultation visible on your area for the next 10, 15 days. So that's an output. And the color here correspond to those we prioritize compared to those which are low priority. And the prioritization is based on the quality of the occultation, but also the interest of the occultation. Is that an NEA, a Trojan, a target of a citizens of a target of a mission, or something that you ask us? One of you ask us to observe, for instance, to add an occultation in the program. We will prioritize it because we assume that the entire IOTA network is aware of it. So we're gonna have multiple codes. So that's the way we prioritize by the color at the moment. This will change over time. We have, as I mentioned, we're gonna have a user account, so people will be able to tag observation they want to do, put them on the calendar, get warning about it, etc., and converse about that live as well. When the occultation is taken, you'd upload the observations using our app to our server, and then we do the analysis as I mentioned. After a lot of requests from a lot of you, we have now allow access directly to the data on your telescope. So you don't need to upload the data to get access to them anymore. We can just get them on the fly while you just shortly after the observation. If you want to do a quick analysis, or if simply you don't want to share your data with the Unistellar network, then you can have them and keep them for you and delete them and do your own data processing using Tangra or any other software. So when the data are being processed, they pop up. There is a bot that we created on our Slack channel that will basically give you some information about the data processing. Ultimately, what we want is to be able to submit automatically this to the occult software with using the OBS XML file. We're very close to be able to do that. I think it's going to be done in February next year for all the 2024 observations. So this is our Slack. You can access to it only if you have our telescope. That's really the point here. So that's where our citizen scientists discuss with each other. So there is a bot occultation, which is automatically posting new results. There is 1,700 people. I captured this like just a few minutes before my talk. So for instance, you can see that there is one observation. Oh, I'm a bit too fast here. Let me see. So that's a text, some information. But one observation on 1998 VF25 in September. This is an observation of 2001 SA317 observed by this user. So we have his video. You can see if there was an occultation. And here we can see there is no occultation for this one, even though the report said that it's positive. So this has been detected by our AI detector. Joseph answered to the observer. I mentioned that this is not a positive, that was clouds. So we're working on this. It's going to be on this as the label as a complicated one. This one is 2001 UC74. Negative. This one is negative as well. Croatia was observed recently, and it's a positive one. So you can see again the movie. Okay, this is a typical format of our movies. You're gonna see the disappearance of the star. At the bottom, you have a report that is sent to via Slack to the users and to the entire community. And here's the information about the positiveness, who observed it, and so on. And this is our AI called Odinet that detects a positive occultation. So we have a paper describing that in more details. So this was the first observation of this guy. He got a telescope recently and he observed an occultation. The reason they observe an occultation first is because it's short and they can easily see if they're positive or negative. So really, it's the best way to attract people to citizen science. And we have also channel here. You can see paper, etc. Because when we have finalized the analysis, we put together the observers and the lead, and we write a paper all together. So we are writing a paper, for instance, for Oersted, and there is a channel for that. And our everybody who has made the observation of Oersted, successful, positive or not, are basically co-author of the paper. That's a policy of Unistellar SETI Institute, and it will not change. We always make sure that the observers are co-author of the paper, if they want to, of course. So to finish, this is kind of where we are in terms of growth. So we have now, last year, we have 6,000 observations collected by all our network. This year, 2024, we expect to have between 10,000 to 15,000. So we're growing exponentially, I would say. For occultations, we took kind of a break in 2023 because the manpower, I was the only one leading this effort. And as you probably know, I have multiple jobs. So this is a bit complicated to be able to do everything. So we took advantage of the year 2023 to test the limit of our system by getting a lot of occultations. Most of them were negative, but a different inclination, different brightness, different duration, etc. So that allow us to tune basically what are the sweet spot to make sure that if an occultation is positive, we will detect it. We have our algorithm. So we have found this sweet spot now. So in 2024, we are focused on getting the largest occultation involving largest asteroid, larger than 5 kilometers mostly. So we have a lot of positives. So we're training our algorithm, our AI algorithm better. And in 2025, we're hoping to start doing again more challenges occultation, but we will need some targets from the community at large. So that's why I'm giving this talk, because I would like IOTA to be more involved. And David Dunham, I really appreciate you send me emails, by the way, from time to time about your targets. Please do not stop doing that, because that's perfect. That's what we need. But I would like to kind of more formalize this collaboration in the future, maybe have access a few months in advance so we can implement those events and tag them coming from you. So this way your community knows that we are working together. In 2024, we have already a lot of positive, as I mentioned, 10 positive detection, and we are going to submit those in February 2025 to Occult by generating automatically these OBS XML files. And so the goal for this year, for this semester, is really to finish the reanalyzing all the data in 2022 to 2023 and send them to Occult. So this is almost done. I would say it's 95% done. There is some fine tuning, but that's all. We're going to update our AI algorithm so it detects very short occultation, because for the moment it's not the case. We have to manually tag occultation when they're detected on less than 3 frames. So that corresponds typically to a duration of more than 300 milliseconds. We're going to submit all the occultation analysis for 2025 by February 2025. We have now a reliable resource to do this analysis. We have everything on Google Cloud Services, so that's allow us to do that faster and quicker. The growth of this network continue. I mean, we have 15,000 telescope in less than 4 years, and we expect, because we're still selling a large number of telescopes, we expect to get 25,000 next year. What is interesting is that we're diversifying significantly where those telescopes are being purchased. They're not only in the US now, but they're really across the entire America, so South and Northern America. So it's going to allow us to get more observers in this part of the world. The arrival of Charles University is extremely useful because it finally allows us to have one single point of contact for occultations, to do more science, to publish paper quicker. And something I really want to mention is that this network is extremely different to the other ones where you have seen. If you talk to our users on Slack, you will see that we have a lot of people of color, a lot of women, a lot of very young people who buy our telescope, and then they get hooked with science, and they love doing the science, and they love doing the occultations. So there is something here that we need to develop to another level, but I'm very happy to see that our network has been attracting young people and the diversity of this country into astronomy. And I will end here. Thank you.
Yeah, I have a question.
Yeah, go ahead.
Yeah. After an observation, how long does it take you to get it uploaded to IOTA?
So right now it takes a year, but the goal is to discuss with the team here so we can do that automatically. So one thing we didn't want to do is to do it automatically until we were truly confident that our pipeline was working properly. And when I say working properly, I want our pipeline to be able to detect if an occultation is positive and negative and be successful like this for 95% of the cases. And we have been training our algorithm, our AI algorithm, to make this detection positiveness and negativity better. And also having an algorithm that will tell us if there is no way we can derive if an occultation positive or negative based on the environment. So we're working on this, and Peter and Joseph mentioned to me that they're done processing 2022 to 2023, and they have reached 95% confidence. That's what we call on the result. So if that's the case, next year we will make sure that as soon as occultation is processed, it can be stored and sent to IOTA. We need to find a way to do that because we cannot do it by hand. We have to find a way we can do it automatically because there is this. We receive way too many occultation to be able to do this by hand. So right now, Joseph is thinking about connecting, creating a bridge, a database, basically with only the OBS XML, and that will be sent to Occult. But this is a point to discuss, of course. Any other questions?
Oh, I see Ted. Oh, Ted Swift is applauding. Thank you, Frank. That was great.
Thank you very much.
Very exciting.
I'll ask a question.
I had one question. When you mentioned that you didn't have many multi-chord observations, did you have multi-chord observations where some other chords were non-EV scope observers that combined with yours?
For OS, we have that. For Eurybates as well. We did a campaign for Eurybates. I forgot to put this on this slide. In fact, 2 years ago in Europe, and we have 18 chords of Unistellar and 12 positive chords from other systems. So we do work with others. What we don't do the processing of other observations, but we put them together if needed.
Understand.
I have a question on the future telescopes.
Yeah.
Is there any plan to make larger apertures?
I'm an astronomer, so we say yes. But it's not yet. One of the problems we have with larger aperture is gonna be heavy to carry around. So we want to make, if we make a larger aperture telescope, it will have to be something that is compact enough to be able to be carried around without being cumbersome. You probably know that Celestron released the Origin, which is a 6-inch digital telescope. I don't know if you can do occultation with that yet. I don't have one. But I will probably test this in the future. For us, the market of small telescope like this one, it's significantly larger than the market for big telescope. Most people live in small houses or small apartment, so they don't have the space to put a gigantic telescope in their backyard. So we don't say no, but it's not yet something on the that we have yet scheduled in the future.
I'm gonna go ahead and have my sandwich. Do you want to make a smoothie?
Yeah, when this is over.
How long is that?
Andy, you need to turn off your mic.
Oh, there we go.
Okay.
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 Thank you
Thank
very
you.
much. Now, we are scheduled to hear from Roger Venable now, but I think, as everyone knows, Roger hasn't been able to join us due to the hurricane. So I believe Joan Dunham is offering to present one of her presentations from tomorrow, today, and then hopefully Roger will have his power back tomorrow.
Okay. I was wondering if Risto was willing to talk. Maybe he would talk now, but I don't see him on.
I think it's early in the morning for Isto yet.
Oh, okay. That's why he was late. Yeah, all right. Because he's at the end, and there's this gap between now and the end. So um, I don't have any contact information for him other than what he's got from email. So yes, I can give a presentation if you would like. Talk about
That would be great. Thanks.
okay. All right, I'll talk about using a Windows 11 laptop for occultation recording, a completely different topic. Let's see if I can find it. Oh, first I need to share. Oh, well, wait. Just a minute here. IOTA.
Perhaps at some point during this talk, Joan, you can share with us the story of that building behind your head.
Yeah, right. Right, that is here we go. Nope, it's not the right one. Oh yes, here we are. And I will share my screen now, which is here. And this doesn't look right. Okay. What? It's a double button.